Hello guys, in this video we're going to look at the differences between three types of sorts or the three types of basic sorts in Java. The bubble sort, the selection sort and the insertion sort. All three of them do the same thing, but let's see how they are different and on what functions are they based on. So what is bubble sort? In bubble sort, we take the greatest number and put it at the end. In the next iteration, we take the next greatest number and put it in the second end. So basically, bubble sort is when we take the biggest number and push it to the end. So let us see how bubble sort works. So now in bubble sort, we're going to take, now for this number, we're going to check between 7 and 4, which is the greatest number. We'll do a comparison between 7 and 4. So 7 is greater than 4, so we'll switch the positions of 7 and 4. Now in 7 and 9, we're going to do a comparison. 9 is greater, so we'll keep 9 in its own place. Between 9 and 2, we're going to cut off 9 from here, put 2 here, and we're going to put 9 here. Between 9 and 5, we're going to cut off 9, put 5 here, and we're going to put 9 here. So in the first iteration, we got 4, 7, 2, 5, and 9. So that will be our first iteration in the loop. So 4, 7, 2, 5, 9. Now in the second iteration, we're going to check between these two numbers, 4 and 7. They are fine. So we keep 4 and 7 like that. So 4 and 7 remains. Now between 7 and 2, 2 is smaller. So we're going to take 2 front and put 7 here. 7 and 5, 5 is smaller. So we're going to take 5 and put it. And we're just going to put 7 here and 9. We don't even check between 7 and 9 because we automatically know that 9 has to be the greater end. 9 is the greatest number, therefore it's at the end. So 7 has to be smaller. So this is our second loop. Now in the third loop which we run, we're going to check 4 and 2, which is greater. 2 is greater. So we're going to take 2, put it in front, then put 4, then 4 and 5. 5 is greater, so we're going to put 4 in front, and we're going to just place 5 there because we know 7 and 9 is already the largest numbers. So 2, 4, 5, 7, 9. In the fourth iteration, we're going to check between 2 and 4. 2 and 4, which is greater? 4 is greater, therefore we're going to take 2, put it in front, which is already in front. If it is already, we're not going to change the position. If it is not, we're going to change it. Therefore, in the fourth iteration, we've got the final loop. We're going to run this. So technically, the length of this number is 5. So we're going to run this whole loop 5 minus 1 times, that is 4 times, because we know in the last iteration, 2 is the smallest number. Therefore, our final array will be this. Now let's check how we can put this in code form. So now I'm going to IntelliGen created a new Java file. So I'll just say class bubble sort. And then I'm going to put public static void main string args. Now I'm going to start. So now I'm going to declare an array of maybe the same array we're taking 7, 4, 9, 2, 5. Now, I'm going to take the length of this array and store it in the variable n. So arr dot length, length. So the length of this array is stored in the variable n. Now I'm going to run a for loop to check it. So I need now we're going to get an outer loop and an inner loop. The outer loop is running n minus 1 times, it's 4 times. So I'm going to declare a variable int I equal to 0. Now I have to run it 4 times. So I less than n minus 1. I should be less than n minus 1. Then after every loop, I'm going to increase I by 1. That's our for loop. Now I'm going to put another for loop because we're going to compare each result. So the first time we're comparing 4 times. The second time we're comparing only 3 times because we know our last number is already in its correct place. In the Third time we're comparing only 3 numbers because we know the last 2 are already in its correct position. So I'm going to take another variable int j for int j equal to 0. And now how am I going to take? J is less than n minus I minus 1. So j is less than n minus I by 1 is basically, technically, because we know n is the number, and minus 1 will give you the 4 times, and then I. So in the first loop I is 0, in the second loop I is 1. So in the second loop we know 1 is already in its correct place, one number, so 1. So we're minusing that and doing it that many times. And I'm going to say j plus plus. Now I'm going to run another for loop inside this. So let's run the for loop, and in this I'm going to do the comparison. So if ARR of index j, that is j is first 0, the 0th index, is greater than the index of 1. So I'm going to put j plus 1. Then in this case, you're going to swap, basically swap the position with the next one, So how do I swap? I need to make a temporary variable. So t, so I'm going to say int t equal to ARR of j. So whatever is stored in j will be stored in t right now. Now in this position of j, I'm going to store j plus 1. So I've stored j plus 1, and in the position of j plus 1, I'm going to store t. So I'm just basically swapping the two positions. Now that's it. So now we just need to print the array. So let's take a variable int a equal to 0. Let's just do it quickly in a while loop. Int b equal to length, ARR length, and this would run a while loop. So while a is less than equal to b minus 1. If I do not put b minus 1, if I just say b, the length of the array is 5, and there are 4 indexes because indexes start from 0, 1, 2, 3, 4. It will say it is out of bound. It will say array out of bound. So we need to actually put b minus 1. Then in that case, you print the position of a plus, give a few spaces, and then increase a plus plus. So this technically should run our program. So just hit run, and we'll get the okay, I forgot semicolon. With this, we're going to get the actual value, that is 24579. If you want it on one line, you can just remove the printf and just put it like this. It will run it all in one line. Therefore, it is sorted using bubble sort. To arrange the array in a descending order, we just do the exact same thing, but instead of taking and putting the biggest number at the end, we put it in first. Now coming to selection sort. Selection sort is just the same as bubble sort, same logic, but in bubble sort we take the largest number and put it at the end. In selection sort, we take the smallest number and put it in the first. In bubble sort, we are comparing and switching every time. So every for loop, we are switching about 4 times, then next 3 times, then 2 times, then final 1 time. But in selection sort, we switch only once per iteration. So let's see what is selection sort. So now let's take the smallest number as index position 0. So this will always become 0, 1, 2, 3, and 4. So now if we take the index position 0 as the smallest number, we will compare S with 4. Is 4 smaller than 7? Yes. So now instead of taking it as 0, we're going to change it to 1. between 4 and 9, we compare. Is 4 greater than is 7 greater than 9? Is 7 greater than 9? So we know that 4 is lesser than 9. So 7 remains in its position, but 4 is lesser than 9. So we're going to take 4 and it'll continue to be 1. Now between 4 and 2, 2 is smaller. So we're going to cut it and take index position 3. Now between 2 and 5, 2 is smaller, therefore 3 remain. So finally, at the end of the inner loop, we're going to switch just 2 and 7. Yeah, the rest remains in its own position. So this is the loop. So 2 comes here and 7 goes here. So let's run the loop the second time, the outer loop the second time. When we run the outer loop the second time, we know that right now, this is this we know. So in the next time, the smallest will automatically be taken as 1. Now when we take 1, we're going to check with 9. No, it is 1 remains. We're going to check 4 with 7, 1 remains. 4 with 5, 1 remains. So we switch between the same position. So 1 will be switching with 1 itself. So this even after the second loop, it's the same array. Now the third time, we're taking the smallest as 2, index position 2, and we're going to check with 7. Is it greater? Yes. Sorry. Is it greater? Yes. So we're going to take the smallest as 3, and then now we're going to check 7 with 5. So no. So we're going to take it as 4. So right now we're going to switch 5 and 9. Index position 4 with index position 2. So this is we're switched to 5 and 9. And in the last time, we're going to check 7. We're going to take S as 4. We know we're going to check it with, S as position 3. We know 3 and 4. 3 is greater because the index position 7 is smaller. The index position 3 is smaller because it has 7. So it will switch with its own position, and this is the final array. So technically, unlike in bubble sort, in selection sort, for every outer loop, we are swapping only once. We're swapping only the small number. Now let's check how the same thing looks if we put it in code form. So I've created a file, class selection sort. Now I'm going to start doing it. So I put public static void main. Let's declare an array. So we're going to declare an array 7, 4, 9, 2, 5. Now we're going to store the same array .length length. Now, one by one, we're going to check the array. So the for loop of the outer loop remains the same. Int I equal to 0, I less than n. In this case, I plus plus. I less than n. In this case, n minus 1 we have to take it as, because it's running only 4 times. Now we are going to check how we have to find the smallest element in the array, in the first loop. So how can we find smallest element? So we're going to take int smallest, or we'll take int s equal to I. That is position 0, like I've already taken. We're assuming this. So now we're going to take another j equal to I, that is 0, plus 1. So we want the next position. So then we're going to check if j is less than n. Till j becomes less than n, that is number of times n is the loop, so j plus plus. Now the I remains the same, but with j changes. So with every loop, we are checking it with each and every number. Now in this loop, I'm going to add an if statement. If now we're going to check by chance, even if array's smallest element is greater than the array's next element, Then we'll do something. We don't need these two here technically. Yeah, we don't need these. Then what we're going to do is we're going to set S to J. That's the smallest element. So we're going to just set the positions. So after all this, we're just going to swap up the way we just swapped it up. So 1 second. Swap. That's it. We're just going to swap up everything the way we have to just swap it up. The same way we did it in the bubble sort method. T equal to arrays smallest element. Arrays smallest element will be equal to arrays I, and then arrays the I will be equal to T. Now we can print this whole loop that should end it. We can print int A equal to 0 the same way we printed int B equal to array dot length while a less than equal to b minus 1. In this case, system.out dot print is going to print arrays a arr a plus a few spaces, then a plus plus. So a equal to a plus 1. Any method would work. Run. Okay. Oh yeah, we forgot. And then this should run. Therefore, it's given us the smallest list. So for every iteration, it's switching the position or swapping only once after the inner for loop. Now the last type of sort is insertion sort. Out of these three, insertion sort is one of the most, or is between these three, it's a little more difficult to understand. So technically, we are not checking greater or less. In this kind of a sort, we are dividing the array into two parts, a sorted array and an unsorted array. So technically, in the first iteration, we're dividing 7. We're going to take 7 as the sorted array, and we're going to take the rest as the unsorted array. Now, we're going to take the first element of the unsorted array, 4, and check it with 7. Is 4 greater than 7? No. So we're going to push 7 inside. So now it's going to become 4, 7, 9, 2, 5. In the second iteration, these 2 become the sorted list, and these 3 become the unsorted list. So technically, as we move on to the for loops, the number of elements in the sorted list increases, and the number of elements in the unsorted list decreases. So this is the first iteration. It was 4, 7, 9, 2, 5. Now in the second iteration, we're going to check if 9 is greater than 7. With the 7, no, it's not greater. So therefore, we can directly put 9 after 7, because we already know. We don't need to check it with 7, because we already know if 9 is greater than 7, 9 has to be greater than the first element because it is smaller. So this is the same thing, and this will be the sorted list. This will be the unsorted list. So now in the third one, I'm going to check 2. Is 2 greater than 9? No. So we're going to take 9 and put it here in the fourth place. 5 will remain as the unsorted list here. Now we're going to check, is 2 lesser than 7? Yes. So we're going to put 7 in the next position. Is 2 greater than 4? No. So we're going to put 4 here, and then we're going to put 2 here. So this becomes a sorted list, and this becomes the unsorted list. So see, in this first one, this is sorted. So it's, if you see, the sorted list is increasing. And in the last loop, now 5 is greater, is 5 is lesser than 9. So 9 goes at the end. 5 is lesser than 7. So 7 goes at the end. 5 is greater than 4. So 4 remains in its own position and 2 remains. Because 5 is greater than 4 and in the middle, 5 comes in. So now finally this whole thing becomes sorted at the end. So that is 2, 4, 5, 7, 9. So this is basically technically insertion sort. Let's take insertion sort and put it in code. Okay, so let's take the array the same few statements as the first. So it's 7, 4, 9, 2, 5. Now we're going to take the length int n equal to array dot length. Now we're going to start the for loop. So for I equal to 1. So this time we will take for int I equal to 1, I less than n, not n minus 1, n, then I plus plus. Now see, now we're going to take another variable k equal to the array I, the position I of the array. So we need to know what is position I, that is 1. Now we're going to take the while loop. We're going to add a while loop in this whole thing. So I'm going to say while j is greater than equal to 0, because the moment we take j as less than 0, there will automatically be an error called array out of bound, because 0 before indexed position 0, there's nothing. So we'll keep that position will always keep running. An array of I has to be greater than key. Sorry, not key, sorry, k. So I should be greater than k. Okay, I think I forgot. Okay, sorry, int j, I forgot to declare j. J is basically I minus 1, that is 0. Technically, I is 1 here, so it becomes 0 here. Now, in the while loop, let's add some more code here in the while loop. So in the while loop, the array position, if this comes true, that is j is greater than k, that is j, that is position I, that's 1, is greater than k, which is I itself. Sorry, array j, that is j is greater than k, that is if position 0 is greater than position 1, then swap. We're going to do a little swapping technique. So array j plus 1, we're going to make that array as array j of position j, and j equal to j minus 1. That is what is our for loop. And then outside the while loop, it's just going to add a little more condition, saying array j plus 1, j plus 1 will be equal to k at the end of the loop. So j plus 1, so technically j equal to j minus 1. Here j was I minus 1, 0. So 0 equal to 0 minus 1. That's minus 1. At the end of the loop, when it becomes minus 1, it will go back. It will check if j is greater than 1. Greater than 0. No, it's not. That's why only the first two get sorted. Now the next we're going to make j as 1. Now when j becomes 1, here j will become technically 0. So in the second time, here j will be 2. 2 minus 1 is 1. J will be 1. J will be 1. So 1 minus, it will run once. Then 1 minus 1 is 0. 0 is greater than equal to 0. It will run the second time. So 3 will get sorted 2 times. The next two, j will be 2. So 3 times it will run. So we want the loop to be running first only once, then twice, then thrice. That way, each element is getting sorted out by itself. Now, at the end, we can just grab our print statement. to print the whole array. LNGTH, then while a is greater or less than equal to b minus 1. In that case, system.out print array a plus a few spaces. A plus plus or a equal to a plus 1. So I'm going to run insertion sort, and that will give you the loop. Where shape there you go. Now we've got our loop. So oh no. So there's a bug. Okay, so we're just basically not printing the first, so I'll just change this 1 to 0. My bad. Now, finally, if we have got printed our array using insertion sort. The time complexity for all the 3 types of sorts is the big O n squared. So which one would you use? Heck, obviously, there are better ways to sort things in Java, such as the quick sort or the merge sort. But these are the 3 basic types of sorts that we should know. If you like this video, like, share, subscribe.